Let's build Schmutzli's naughty list, a Prof G SwiftUI exam challenge and solution. And just a quick note, if you're new here, welcome. You might want to check out the playlist where you can see the over 100 high-quality lessons used in my university course that my students have gone through to arrive at this point. And you see the app being demonstrated below. Alright friends, this is the first of two apps that students needed to build as part of their final exam. This one emphasizes SwiftData as well as a number of SwiftUI and Swift language features. Now the rules of my exams are that students take exams in real time over a 2.5 hour period in class on their MacBooks. They can use a single page of double-sided notes with anything on them, but they cannot open up any old code files, they can't use any AI that's not part of PredictiveCodeCompletion built into Xcode, nor can they consult the internet or any other resources. And the reason for this is because I want them all to be reasonably well prepared for code interviews where you can't really look it up when you're asked questions. To Americans, Christmas traditions in other countries can sometimes seem a bit odd. Switzerland, for example, has Schmutzli. Schmutzli is a dark, mysterious figure who is sort of a naughty sidekick to Sammy Klaus, the Swiss version of Santa Claus. He's often depicted carrying a broom or a bundle of twigs to symbolically punish misbehaving children. And if there are any Swiss watching this, I've taken a few liberties with Schmutzli in here, don't at me. This past year, we're going to assume that Swiss kids have been out of control, cow-tipping, rolling cheese downhill at unexpected hikers, spiking cocoa. It's utter mayhem in the Alps. Schmutzli has heard of your Swifty skills and programming prowess, and he has asked you to build him Schmutzli's Naughty List, an app that he can use to keep track of individual Swiss children that he needs to monitor. This app will use SwiftData to show the list of children. It will initially be empty, and each child can be classified as naughty or nice. Nice kids deserve 0 smacks, while getting on the naughty list earns at least 1 smack and may possibly get as many as 5. Schmutzli is a dude to be avoided, even though his smacks are meant to be playful and can be experienced in many public settings when you normally would see Santa. He wants to practice his smacks, so he's also asked you to put a small Swiss boy and girl on each detail page so he can practice swatting kids whenever he wants to. I know, super weird, right? The image will bounce and produce a smack sound similar to what my students have built in their Bip the Guy app. This is a look at what the app should look like when it's done. You're going to build out the features one by one, following the steps below, and if you get stuck in a particular section and it looks like you can't progress, create constants or some other mechanism to work around what's limiting you so that your instructor can still evaluate your work for partial credit. Good luck, and stay off the naughty list. Now the first thing that we're going to do is we're going to create a new SwiftUI project for the app called Naughty List, and we're going to download images, sounds, and icons from the Naughty List app at the folder that we've been using throughout our course. We want to add the icon to the app's icon, and the logo to be used as the app's launch screen, and all other files should be added to our assets catalog because we're going to use them in the questions below. I'm going through this solution much faster than the detailed explanations I usually offer in my lessons, and the reason for that is that my students have already seen these techniques and have done them multiple times in class examples, so if they're watching this to see what they missed, they likely just need a brief explanation to point out an issue or technique. So in Xcode, create a new SwiftUI app. We're going to call this Naughty List, and you can save that anywhere. I'm going to save mine to the desktop. Then I'm going to head over to the asset catalog. I'll click on app icon. I've already downloaded the Naughty List files, but again, the URL lists where you can find those online. I'm going to open that up. The first thing I'm going to do is I'm going to drag the icon into the icon folder. Then I'm going to drag all the other files except for the icon and drop them into my asset catalog area. Then to set up the launch screen, I'm going to click on the app icon at the top of my project navigator, click on the info tab, then head down to where it says launch screen, click the exposure triangle and click on the plus sign to select the option to add an image. I've got to give an image name. My image name is Logo, L-O-G-O. As we'll see later on in the simulator, this will show up as our launch screen. We'll have an icon, and a bit controversial, but I like to convert my folder to a group and rearrange things old school style. Now in question number 3, we're going to create a class named Child that we will use to keep track of all the properties for each child on the list. You want to create the class so that it can properly use SwiftData, and the class should include the following properties: first name, which is a string, last name string, naughty a bool, smack int, notes string, and do everything that's necessary so that this class produces no errors. You see the default values, and let's build. So to create the file, I'm going to right-click on Naughty List app, select new file from template. This is going to be a Swift file, not SwiftUI template. It's called child, capital C, because this is a data type. Since we're going to work with SwiftData, we want to import SwiftData, then app_main_actor and app_model, so that we use the model macro. We'll say class, capital C, child, open and close curlies. I'm going to paste in all of the values that I copied from my exam, make sure that these are all vars, and I'm going to set them equal to the default values. Xcode is angry, my friends, and the reason why is because we don't have an initializer, but we can just type init and tab over. Xcode will write the rest. Always double check to make sure that it's initialized the values properly. With your defaults, it has. So let's head back over to question number 4, and in this it wants us to set up an extension to the child class that includes mock data that will have the following properties. So we want to have first name, last name, naughty, smacks, and notes with all of this information in here. Again, this is only for our preview data. Our students have learned how to do this and they've done it multiple times in class. So I'm going to copy this data so that I can paste it in as I'm creating my mock data. Now, you don't have to add this to an extension, but I think that's a nice organizational thing to do. So down below the last curly in the class, we'll say extension, capital C, child, open and close curlies. Our mock data is a static variable called preview. Static variable means we don't have to create an instance of a class. We can just refer to the class dot the variable name. So we'll say static var preview colon and then model container, open and close curlies. So that means this is a computed property and we're going to return a model container. First, we got to create the model container that we're going to fill up inside these curlies. So we'll say let container. We could call it anything. Container's a good name. Equals try exclamation point model container. Choose the option with for and configurations in here. For is going to be child.self. In configurations, we want to create a model configuration in here and choose the option with is stored in memory only and set this bool value to true. Now we're eventually going to return this container variable, so we'll put that down below to silence the error, but in the middle we're going to load up the container, and here's how we do it. We say container.main_context.insert, and in between parentheses we're going to pass in child. I'll tab over, although this is incomplete. I'm going to paste the data that I copied from the exam down below. Then I'm going to retype child, and I'm going to select the option that's got all the parameters in here. Hold down the option key, press return. Then I'll add the first child in here, which is Bad Bunny. He is naughty. He's bad after all. He's got one smack coming to him, and the note is that he's Conejo Malo. That's Bad Bunny in Spanish. Then I'll copy this line, paste it down below 4 times, and fill it up with all this extra data. I'll delete the text I pasted below just so that I didn't have to tab back and forth. Again, the technique should be very familiar, and you've got review lessons if you need to go back for more of a description. Then let's head over to question 5, which wants us to modify the app file. That's the first file that executes in our code so that SwiftData will be able to be properly supported. And we're also going to add some code to print out the URL of a directory where we can find our SwiftData stored when we run our given simulator. And from class and our earlier lessons, we know we can use the URL. It's going to print out to the console to find our locally stored simulator data and open it up in DB browser so we can make sure that our data is properly saving. So let's head back to the naughty list app file and set things up for SwiftData. First, we want to import SwiftData. Then under content view, we always say .model container. You want to make sure it's container. Select the option with for, and this tells SwiftData what the format is for data that's going to be saved. That's going to be child.self, our child class. Now to allow us to find out where our simulator data is saved, we'll just say init, open and close parens, open close curlies, and we'll add print, and in between parens, url.application support directory.path, select %encoded, and set this equal to false. Now I also remember question 6 wanted us to change content view so that it's list view. So in content view, we'll just right click on content view in the struct name, select refactor, rename, retype list view, and we can see that this is changed everywhere, including in our app file. Now in the list view for question 7, we want to do the following. We want to create a variable children, which is an array of objects of class type child, and we want to properly read in any existing Swift data if there is any. Now we also want to make sure that when the app runs in the preview that we use our mock data that we created. We want to create a list that will display all children one by one in a variable called child. The name of each child should be displayed as first name, a single space, and last name. The items in the list should be displayed in Title II font. The list should be in plain style, and the list should have a large navigation title at the top of the view that says Schmutzlis list : So back in our newly renamed list view, we're going to import SwiftData, and as our first variable inside of the struct definition, we'll say @ query var children colon, and then in between square brackets, capital C child. We learned this is the ultra easy way in SwiftData that we read all of the data that's of type child that's been saved as part of this app. Now, we got nothing in here yet, but that's why we created our mock data. So let's head down to the preview, and below list view, we'll add a .model container modifier, and we'll pass in between parens capital C child.preview. Now, inside the body of this view, let's start out with a navigation stack, and we'll delete everything between the curlies. And I'm going to add list, open and close curlies, and I'm not going to iterate through the list with the list definition because I'm going to want to swipe to delete inside. I'm going to enter for each. We learned swipe to delete doesn't work for a list. It works for each inside of a list. Select an option with data and content. Data is children, tab over, return for trailing closure. We'll say child as our in variable in here. Then we'll put in a text view, and in between quotes, string interp space string interp. The first string interp is child.firstname. The second is child.lastname. Names are in the preview. Groovy. We'll set the text is .font modifier to .title2. And below the closing curly for list, we'll say .list style equals .plain. And we'll set our .navigation title below this to the string Schmutzlis list colon. And I got some extra padding in the end that was part of the VStack. I'll delete that. Next, for question 8, we want to update each list item to use the image named naughty or nice that we dragged over from the asset catalog, and this should indicate whether or not it is true that the child is naughty or nice. Now, the image should be to the left of the child's name, and it should be no more than 30 points high, and I show you a little diagram down below that shows what this should look like with our preview data. Now, to get this to the left of our text view, I'm going to embed this in an H stack. Then inside the H stack above the text view, I'm going to say image. I'm going to select the option that just allows me to enter a string, a resource name, and I'm going to use a ternary operator in here, child.naughty question mark. If that's true, I want to use the string naughty. Otherwise, colon, I'm going to use the string nice. Those are the names of those two pill-looking images. Below them, we'll say .resizable, .scale to fit, and we'll set the .frame height to 30 points, and this is looking good. Now for question 9, we're going to create a detail view that will accept a value named child, which is of type child, passed in from the list view. Now this detail view should be set up so that it looks like the image that I'm going to show you below, the alignment and the padding and the spacing as shown. So we want to use variables named first name, last name, naughty, smacks, and notes. The user interface setup includes all text fields, text views, and labels with the UI elements below to be in Title 2 font, except for the large number below the stepper view, which should be in large title font. Now the text views include 3 views, first name, last name, notes, all in bold. There are 2 text fields, one with a prompt first, one with a prompt last. Those are in rounded style format. And our third text field also has the prompt notes. You should be able to scroll that vertically if there's more than one line of notes in there, and that should also be in the rounded border style. Now we'll have a toggle view that's labeled naughty question mark in bold. There should be a stepper view with a text field that's labeled smacks deserved in colon with a colon in bold. It should allow the user to select the number of smacks in the range 0 through 5 only. Now the number of smacks should show up in the text view centered below in bold in large title font, and it should change if the stepper is pressed within the range of acceptable values. Now the image views have 2 images, boy and girl, side by side, with bottom of the views at the bottom of the window, sized at the roughly the same size. This should be 250 points tall, and the images should be side by side, centered horizontally in the view as shown. Surround all elements with standard padding, and at this point we should get something that looks like this. So let's code it. So I'll right click on list view and create a new SwiftUI view named detail view. We're going to work with SwiftData, so we should import SwiftData, and the first variable we'll create under the detail view declaration is @state var child colon uppercase child. So it's uninitialized because we're going to pass in a value from our list view. Then I'll paste in the variable names down below so I can create those. You know how to do this. A bunch of state private variables, first name, last name, naughty, smacks, and notes. Naughty's true, smacks is 1, and everything else is empty string. Now, since we're going to Swift data, why don't we set an @environment variable between parens \.model context, which is var model context, and we'll also set up our dismiss environment variable as well. You know how to do that. Now, in our body, we're going to put everything in a VStack with the alignment set to .leading, but first, why don't we head down here and get rid of the error that's showing up in the preview provider. We're going to backspace over, then select detail with a child, and we're going to pass in capital C child with empty parens to initialize this with an empty child object. And since we're working with SwiftData, we'll want to add the .model context modifier down below with the for and in memory option, and for is capital C child.self, and in memory is going to be true. Now why don't we first create those text views? So I'll say text, and that is going to pass in first name colon, and we'll set this to .bold. I'll paste it in twice down below. Then the second one will be last name, and the third one will be notes. We'll add a spacer down below to push those up top. Then let's add our standard text field with our prompt as the string first. Then we'll set the .text field style, a .rounded border. Down below the close of the VStack, I'll set the font for everything inside to be .font.title2. I'll add some standard .padding as well. Then I'll copy the text field in the modifier, paste it down below last name, change the last name text field prompt to last, and the text that we're working with to $last name. And I'll paste this down below notes as well. The prompt is going to be notes, the text is going to be $notes. But then I'm also going to add a comma axis colon parameter in here, and that's going to be .vertical so that I can scroll vertically and add more than one line of notes. Now above the notes, we'll add a toggle view with the title key and is on option. The title key is going to be naughty, ? Is on is $naughty. We'll set this to .bold, and below this we'll put in a stepper with a title, value, and an in selection in here. The title of the stepper is going to be smacks deserved, : the value is going to be $smacks, and the in wants a closed range. We want this to be between 0 and 5, so it's 0, $5. Now we're going to display the selection of the smack number down here in a text view, passing in between parens the string interp smacks, and above this, why don't we make sure that our stepper is in .bold, and below the text, we'll set our .font to .large title. Now to center this view, one thing you could do is you could embed this text view in an H stack and put a spacer above and below the text view. But I want to make sure everybody knows this alternate technique that exists as well. We can use a .frame with a max width of .infinity and an alignment parameter of .center. That uses a bit less code, and we can see it's centered nicely. Now below the spacer, why don't we create an H stack for our images? So we've got an image, and between parens we can pass in .boy. Below that image, passing in .girl. Now if we try to add resizable and scale to fit below the H stack, that's not going to resize things for us, so I'll paste those below each image. Although I'm typing too fast, I need to be capital I image here, and I spelled resizable wrong. Under each of these, I'll add a .frame with a height parameter of 250, changing the resizable below .girl. And things are looking good. There's our detail view. And if we check out the in range inside of the stepper, we can see that we can't go below 0 or we can't go above 5. Nice. For question 10, we're going to work with some detail functionality. So when the toggle is turned off, we want the smacks to be set to 0. When the toggle is turned on, we want to set the smacks that were previously to 0 so that they're 1. When the smacks are set to 0, so we move down with the stepper, we want to make sure that the toggle is turned off. And when the smacks are moved up to 1 as well as 2 through 5, using the stepper, we want to make sure that the toggle is turned on. So for full credit, you want to use ternary operators rather than any other conditionals, so no ifs or switch statements, and the effect is equivalent of being able to change either the toggle or the stepper, and if the stepper is 0, the toggle will always be false, and if the toggle is false, the stepper is always 0. Similarly, anytime that the stepper is not 0, the toggle must be true. You see some examples of what this looks like below. Let's code this up. So let's first work on what happens when the naughty value is changed. So up here below the naughty toggle, we're going to say below the bold modifier .on change. We'll select the option with of and action. Of is what changes, that's naughty. Tab over, press return for action. In between the curlies, well, think about this. We want to change smacks. So smacks is going to equal, and then this is going to be a ternary operator, which acts like an if statement. We'll say, how about in between parentheses so it's a little bit easier to read, naughty double equals true. So if naughty is true, and actually we didn't need the double equals true, we could have just put naughty in here because it has a true or false value inside being a Boolean. But if naughty is true and, so we'll say ampersand ampersand for a compound conditional, smacks double equal sign 0, well, we shouldn't have a condition when they're naughty, but they have smacks 0. So after the question mark, if that's true, we'll set smacks to 1, : otherwise we'll set smacks to smacks. Now we also want to deal with the opposite condition, so below this we'll say smacks equals, and in between parentheses, naughty double equal sign false. We could also have said exclamation point naughty. That's the opposite of whatever's in there. So instead of it registering as true, it would register as false. So if we have a false and naughty question mark, we want to put a 0 in here, : otherwise we want to say smacks. So if they're naughty, we're going to make sure that they don't have 0 smacks. If they're not naughty, we're going to make sure they have 0 smacks. Now we'll do something similar down below the stepper. We're going to also add a dot change of and an action. The of here, though, is going to be smacks that changes because this is below the stepper. And here there's only one conditional we want to look for. We want to change naughty, and we want to set that equal to the ternary operator between parentheses, smacks double equals 0. If that's true, question mark, we want to set naughty to false. Otherwise, colon, we want to set naughty to true. So now let's try this out. I'll down stepper to set smacks to 0. We see the naughty toggle goes off. Stepper up, we see the naughty toggle goes on. Clicking off the naughty toggle sets the smacks to 0. Turning it on sets the smacks to 1. You need to have at least 1 smack if you're naughty. And you can fool around with this, but this is going to work fine. Nice. Now let's head over to question 11 for smack practice. So again, Schmutzli is a bit of a weirdo. He wants to be able to practice smacks even if kids are not naughty. So what we're going to do is we're going to allow tapping a child image to play the smack sound. You copied that over into your asset catalog earlier, and the smack should also pulse in the same way you pulsed the image in Bit the Guy. As a reminder, the spring values used in Bit the Guy were moving from scales from 0.9 to 1.0 in size, with a response or stiffness from 0.3 and with a dampening fraction, also known as drag, of 0.3. So let's code this up. So first, we know when we work with audio, we want to import AVF audio, and we're also going to create a state variable for an audio player with @state private var. We'll call it audio player : it's declared but not initialized. It's AV audio player, and it's an implicitly unwrapped optional, so we put an exclamation point after this. You've done this a bunch of times in class and in your video lessons. Then we can add our play sound function. How about just before the closing curly in the struct? And in fact, you've created a play sound function so many times, I'm not going to bother to read this out or go through it. If you need a review, you know where you can find the play sound function lesson in our lessons playlist. But now that we got the play sound function set up, why don't we add a .tap gesture just below the image of the boy. In between curlies, if this is tapped, we're going to call play sound, passing in the string smack. Then I'll copy this tap gesture, we'll paste it down below the girl, then we can try this out, and you can tap on either of these images. You're hearing the smacks, sounded good. And now I reminded the class in studying for this test to make sure that you knew how to do the animations, especially what we did in Bip the Guy. Now to remind you, what we're going to do here is underneath, we'll start with boy, we'll say .scale effect, and what we're going to put in here is going to be a ternary operator. You see, we want to alter the scale effect whether or not a particular variable is true or false. So up top, we're going to create @state private var. We'll say animate boy, and we'll set this equal to true. And we need another one for the girl image, so we'll say @state private var animate girl equals true. Now in the ternary operator here, inside the parens, we'll say animate boy question mark. So if this is true, we want to set the scale effect to 1.0, the full size, colon, but if it's not true, we want to set it to 0.9. That's going to scale down as part of the with animation below. Now inside a tap gesture, if the image has been tapped, we're going to take animate boy and we're going to set it equal to false. Now this is going to immediately shrink to 90% using the scale effect ternary operator above. So you tap the image, it immediately shrunk down by 10%. But now down below, we're going to select this option with animation. We want to select this one with the animation and the body. I'll tab over to body and press return so we get trailing closure, then head back to the with animation parentheses. Now in here, we're going to set a .spring animation. And it's not easy to select the variables we want, but we can just start to type in RES for response and DAM for damping. Both of those are highlighted, press return. Both those options show up. And we're going to put 0.3 in both of those. Now response and damping fraction are sort of physics settings. So response is the stiffness of the spring. A value of 0 is an infinitely stiff spring, so not springy at all. The damping fraction is drag. We messed around with these options previously. 0.3 and 0.3 is a nice spring effect. And inside the curlies, we're going to set animate boy back to true. So we're going to head from 90% back up to 100% as we animate. And I said down here that it takes over 0.3 seconds. That's not entirely true. It's actually really based on the physics settings, and they're not directly correlated to a seconds value in here. But this is going to work fine. So again, animate boy was 100%. When you tapped it, we immediately shrunk it down to 90%. Then we executed with animation with these springy values, these physics values. And on our way back to setting animate boy to 100% again, we reached that value, but we sprung while we were doing it. That's how these values work together. So if we click boy, he springs. If we click girl, she doesn't spring yet, but she makes the noise. So with this set up for boy, I'm going to highlight everything from the .scale effect through the closing curly and on tap gesture. I'll paste it over the on tap gesture for the girl image, but I'll change any reference to the animate boy variable to animate girl. So now let's try these out. Smack the girl, smack the boy, smack the girl, smack the boy. We see they're springing. Only the image we touch is springing. Nice. So now let's head down to question 12 where we can get SwiftData working. So in the detail view, we want to set up a toolbar with a cancel button. If you click on that, that'll allow us to leave the view and return to the list view, and it should be placed in top bar leading. A save button should either save a new entry, or if we're editing an existing child, it should update any changes to that child. After saving, the user should be returned to the list view as well, and this button should be placed in top bar trailing. Now there should not be a back button that's showing when the user is getting here from the list view, and at this point we expect that the detail view is going to properly show all of the elements in its preview, which means make sure that you embed the preview in a navigation stack so that you can see the toolbar. Although to actually save data using SwiftData, we need to run things in the simulator. Now I could put the toolbar anywhere because the navigation stack isn't on this view, it's from the previous view. Right here I'm putting it just inside the closing curly of the VStack, but it would have been totally fine to put outside of the VStack as well. Then I'll say .toolbar, open and close curlies with the toolbar item placement and content, placement top bar leading, and in the closure, we're going to select a button with a title key and action. And actually, Xcode is getting weird on me in here. It's not showing an option with title key and action, so I'm just going to put in button. In between parentheses, I'll put in my title, which is going to be cancel, the string, and then I'll add open and close curlies. And all we need to do here is call dismiss, open and close parens. Then I'll copy this whole toolbar item. I'm going to paste it down below. I'll change my button to save, and I see I should have changed my placement. We'll change that in a bit. I'll put a to-do in here that says button save here. Also, just above the toolbar, I'm going to say .navigation bar back button hidden. If I didn't do this, then that back button would show up to the left of the cancel button when I get here via the list view, and I don't want that to happen. So now before we save, remember what we want to do. We want to take the value of what's inside of the child variable where we're passing data over from the list view, and we want to update our local parameters that we have for each of the user interface items. So I'm going to add a .appear down here, and again I'll add that, how about just below the padding, that'll be a fine place. So this should show up when this VStack first appears. And we haven't done a whole lot putting inits in views, but you could also put this in a init, but we learned the onAppear. I'll say first name equals child.firstname, last name equals child.lastname. The same for naughty, smacks, and notes. And the reason we put stuff in these holding variables here on the view is that SwiftData will save automatically for us if we go back. So we're not actually updating that SwiftData variable, but I'm going to copy all these because if I do click on the save button, well, I'm going to paste this over our comment here. We're going to move all the UI variables into the child that was passed in. So we're just going to flip everything we did below. So child.firstname is going to equal first name, child.lastname equals last name. Same for naughty, smacks, and notes. And to actually save, and this is either going to add a record or save a record, all we need to do is say model context.insert and pass in child. That's it. If this is a brand new child, it's going to add that new record. If it's an existing one that has an ID property, which is behind the scenes, it will update that existing child with the new data that we'd entered. Now, we don't have to do this next bit, but I always force a save so that we can check it with the DB browser app. So I'm going to say guard let underscore equals try question mark model context.save open and close parens else open and close curlies. Now, if we fail, we'll return, and above that we'll print angry emoji error save on detail view did not work, but hopefully you'll never see that. Then to finish this off, we're going to want to do some work over in the list view so that we can add records. So let's head back and look at question number 13. And again, we've done this plenty of times before. This wants us to add a toolbar to the list view with a system image named plus showing in the upper right hand corner. When the plus button is tapped, the detail view should be presented in a sheet, and this should be presented in a way that the toolbar in the detail view properly shows and functions. So in the list view, make sure that you're adding your toolbar inside of the navigation stack. There I am. I'm going to say .toolbar, open and close curlies. Inside we add a toolbar item with placement and content. Placement's going to be .topbar trailing, and we'll add a button with the action and label. Put into to-do for the action. The label is going to be the image with the system name, the string plus. Now that button is actually going to toggle a Boolean value that we need to create. That's going to show a sheet. So up top we'll say @state private var sheet is presented and set this equal to false. Then we don't need that to do. We can just say sheet is presented .toggle, and then I'll collapse my navigation stack and I'll put my sheet just below that by saying sheet and selecting the option with is presented in content. Is presented is going to be $sheet is presented. It's binding, tab over, press return. Now we're outside the navigation stack here. So to show the toolbar on the detail view, we need to put in navigation stack, open and close curlies. Then we can call the detail view, passing in a child, and this can just be capital C child, open and close parens, because that's going to initialize a brand new child record for us. And while I'm at it, before I test everything out, why don't I head up here and we'll add our navigation link as well. So I'll expand my navigation stack, and just inside for each, I'm going to add a navigation link with a destination and label. The label is going to be this entire H stack down here, so cut that out and paste it into the label area. And the destination is going to be detail view. We're going to pass in a child, and this time it's going to be the child variable that represents the value we're iterating through when we iterate through the children's array. Now we did import SwiftData, but we want to make sure, since we're going to be doing some SwiftData stuff in here, that we set an @environment variable in between parens \model context. We'll set it to private var model context. That's going to be really important when we swipe to delete in just a bit. But let's build and run. Hammer time, no errors. There's our launch screen with the Schmutz, and he's got his broom. We got nothing in the Schmutzlis list. Let's click on that plus. Why don't we add Bad Bunny? And look, we can toggle our naughty button. We can also click on our stepper value, and the behavior is happening exactly as we set it up. We'll enter a note, he's El Conejo Malo. And yes, that one thing I didn't like up here. So the save button, we set these both to top bar leading. I forgot to change this to top bar trailing. Let's do that now. Sorry about this. You probably don't have that problem. So let me build and run again. Then we can see down here we have the directory path that's printed out that tells us where our data is going to be. I'll highlight this just so we can browse using DB browser. I'll select services, open. Select run service, and again, you didn't have to browse in DB browser. It's a nice thing to do to make sure your data is saving okay, but we can kind of see that in the app anyway. Run service opens our application support directory. If we right click on default store and we select open with DB browser, my students learned how to install this in an earlier lesson. DB browser runs, we can select browse data. We can pull down zchild to see all of the child records that we have saved in our SQLite database. That's what Apple is using behind the scenes, and we see we got Bad Bunny in there, nice. Now if we quit out of the simulator, we rerun again, we can see the data that we have in there. Bad Bunny is in there, good. Let's add a new record, Bad Guy. He's really bad, so he's 5 naughties. He's so terrible Billie Eilish wrote a song about him, click save. We got the 2 bad ones in there, let's click on plus and add a good guy. We'll say Fred Rogers. He is not on the naughty list. He's everyone's favorite sweater neighbor. Click on save. We got all 3 records on the Schmutzlis list. We see the naughty and nice flag is updating. That looks great. If you want to click on bad button and say, oh no, that's just his name, we can make him nice instead of naughty. Click save. Everything updates. We can head back to DB browser and refresh this screen. We can see our data is in there. Again, all as expected. So cool, we have the C.R.U. of C.R.U.D functions, create, read, and update. Let's get delete happening. That's question number 15, swipe to delete. So now we should implement swipe to delete in the list view with a red button as we've done in our earlier apps. There are a couple of different ways we can do this. We'll head to the list view, and just below the label close and curly in the navigation link, we'll add .swipe actions, open and close curly, and inside we'll add our delete button, selecting the one with the title key role in action. The title key is going to be delete, the role is going to be .destructive, press return on action. And to delete, this is super simple. We just say model context .delete, passing in lowercase child. Now again, I always recommend to force this in the simulator, so we'll say guard let underscore equals try question mark model context dot save else open and close curlies with a return, and above that we'll print angry emoji error save after delete in list view did not work. And I forgot my parentheses around the save, that's why I'm getting a warning, or after the save I mean. So this is looking good, but let's finish off question 16 and then try things out. Schmutzli likes to think of himself as a real bad guy, so each time the app launches, let's play the sound riff. We've already implemented playing sound in the detail view, now we're just going to do it in the list view. So we need to import AVF audio. We're also going to create @state private var audio player AV audio player exclamation point, and then why don't we head over to the detail view and grab our working play sound function. We'll copy it, head back to the list view, paste it in just below the closing curly in the struct, and then we want to call onAppear. Why don't we do that right underneath the closing curly in the sheet just above this? All we need to do is say onAppear, and in between curlies we'll call playSound and passing in riff, that string, as the sound name. And you should be hearing a riff from Billie Eilish's Bad Guy, but I'm not playing it here so that I don't get slapped by copyright issues on YouTube. But let's do build and run hammer time. You should be hearing the riff, mine is suppressed. Let's click on plus and add another baddie. How about Veruca Salt? She's naughty, 5 smacks for her. Don't let her near candy, Willy Wonka really doesn't like her. You can try out a little smack practice, that's looking good. Click save. Veruca is added. Swipe left on bad guy. Bad guy is deleted. If we go home, we see our nice icon. We can relaunch. If we quit and rerun, you should hear the riff. Mine isn't playing. And at that Swifter, Schmutzli's list is done. I hope you did well. If not, I hope you understand the areas that tripped you up. I hope our new visitors follow along as well, because there's always goodness on the channel. Keep hacking.